Last time we talked about factoring using a variety of methods, traditional factoring, factoring with the difference of two squares, the sum or difference of two cubes, and then we learned how to factor by grouping. Today we're going to talk about how to factor if we don't, how to find factors of a polynomial if we can't use any of those easier methods. So long and synthetic division is how we do that. First, we have to talk about the rational root theorem. The rational root theorem gives you all possible rational roots of a polynomial. It does not give you the roots, and there also could be non-rational roots also. So it could be irrational or complex as well. But if it's a rational root, this is how you find it. And let's say you have some function f of x equals p x to the biggest power plus a bunch of other stuff plus q, where we have p is the leading coefficient of the biggest power term and q is the constant term. Then what we can do to find our possible rational roots is plus or minus all factors of q divided by all factors of p. So I gave you an example. If f of x is this function, I list all the factors of 15, 1, 3, 5, and 15 in the numerator. I list all the factors of 9 in the denominator, and then I just kind of divide them all out. So notice that 15 divided by 9 is the same as 5 divided by 3, for example. So that shows up twice as 5/3. I don't need to repeat them when I'm listing them out. And I actually don't need to list them out all like this. I just did that to show you how it works out. So 1 divided by 1, 1 divided by 3, 1 divided by 9. 3 divided by 1, 3 divided by 3, 3 divided by 9. 5 divided by 1, 5 divided by 3, 5 divided by 9, and so on. So that's how you can find possible rational roots. And that helps us when we're trying to figure out how to divide. Real quick primer on long division, just reminding you that this is a thing that you learned in the past. 42 divided by 7, we choose 6, and then 6 times 7 is 42, we get 0. If this number is 0, that means it evenly divides, there is no remainder. So the remainder term is something that can exist. 39 divided by 6, if I did 39 divided by 6, I would choose 6. But notice I have a remainder. If I wanted to write this, I could write this as 6 and 1/2, or 6.5. And the reason for that is it is 6 plus 3/6. So the remainder ends up getting written, remainder gets written on top of what we are dividing by. Finally, 1054 divided by 8. So in this case, I would look at 10 and see that 10 divided by 8 is 1 with a remainder. 1 times 8 is 8. Then I subtract 10 minus 8 is 2. And I carry down the next term. This is the algorithm for what we do in long division. 8 times 3 is 24. I bring down the 4. And then 8 divided by 14 divided by 8 only goes in one time. So then I multiply 1 by 8 and I get 8, and I'm left with a remainder of 6. So my remainder in this case is 6. And if I wanted to write this, I could write this as 131.75. And that's because I could write it as 131 plus 6 over 8. And again, 6 is the remainder. 8 is what we're dividing by. Remainder dividing by. So that's just a quick reminder that you did learn this stuff in the past. We're going to find all x-intercepts of these. I'll give you a hint. None of these are factorable by the other methods completely on this side of the page or the other one. So if I want to look at this problem, the first thing I'm going to do is use the rational root theorem. So plus or minus 1, 2, or 4 over 1, 2, 3, and 6. That gives me 1, 1/2, 1/3, 1/6, 2, 2/3, 4, and 4/3, plus or minus all of these. So those are all of my possibilities. As much as I possibly can, I'm going to try and avoid using fractions if at all cost. But that doesn't mean that fractions don't exist. It's just if we can find one that's an integer, then that would be nice. So I'm going to try to divide by x minus 1. Note that if I divide by x minus 1, that means that there is a root at x equals 1. So that's something to keep in mind. I'm going to try to divide by x minus 1 first. I'm going to warn you, this will not work. So if you don't want to write this down, that's okay. But I'm trying to show you what happens when you choose something that doesn't work. 6x cubed minus 19x squared plus 16x minus 4. So I'm going to show you some long division. The number that I can put up here would be the number that multiplies by x in order to get 6x cubed. That number would be 6x squared. 6x squared times x gives me 6x cubed. I then have to multiply it by the negative 1. So 6x squared minus 1, or times negative 1, gives me 6x squared. Then, just like when I was doing long division with numbers, I have to subtract what I have. Notice if I'm subtracting a negative number, I have to change that to a positive sign. So these go away, the 6x cubes go away, and I'm now left with negative 13x squared. Just like when I was doing numbers, I will pull down the 16x, and now the next thing I have to do is find a number that multiplies by x to get 13x squared, or I'm sorry, negative 13x squared. That number will be minus 13x. Minus 13x times x gives me negative 13x squared. I then also have to multiply it by the negative 1, so I get plus 13x. I now have to subtract those terms. So I am going to subtract, and I end up with 0 where the 13x squareds were, and then I have 3x. I'm going to pull down the 4. So what I need to do here is find a number that multiplies by x to give me 3x. That number is 3. So 3 times x is 3x. 3 times negative 1 is negative 3. And then I have to change the signs in order to add or subtract. I get the 3x's going away, and then I'm left with negative 1. Negative 1 is not 0, so that is a remainder. Anytime I have a remainder, that means that I do not have an x-intercept. Remainder means I don't have an x-intercept. I want my remainder to be 0. If my remainder is 0, that means it evenly divides it, and that means it is a factor. So that one doesn't work. The next one I'm going to do will work. I'm going to try x equals 2, which means that x minus 2 is the factor that we are going to try. So I'm going to try to divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2. So if I try that, I have 6x squared. I should probably get rid of the circle so then it's easier to see. So 6x squared. 6x squared times x is 6x cubed, and then 6x squared times negative 2 gives minus 12x squared. When I add these or subtract these, I'm going to change the signs. Those go away. This becomes negative 7x squared, and I will pull down the 16x. The number that ends up uh, multiplying by x to give me negative 7x squared is going to be minus 7x. So minus 7x times x gives me negative 7x squared. Negative 7x times 2 gives me positive 14x. I then will change the signs, and then this ends up being uh, 16x minus 14x gives me 2x. Then I will pull down the minus 4. The number that multiplies by x to give me 2x is 2. So 2 times x gives me 2x. 2 times negative 2 gives me negative 4. If I change the signs by subtract this, which means changing the signs and add, I get 0. Notice that 0 being a remainder is a good thing. That means that x minus 2 is a factor. So I can rewrite f of x as x minus 2 times 6x squared minus 7x plus 2. Notice I'm just taking x minus 2 times 6x squared minus 7x plus 2, which should, if I multiply them back together, give me what I started with, which is a logical extension of what I learned from division. If 42 divided by 7 equals 6, 6 times 7 equals 42. Well, likewise, if I divide, get no remainder, and I end up with something like 6x squared minus 7x plus 2, then if I multiplied them back together, I would get what I started with. Now, after I factored that out, I can finish, since this is a trinomial, if it factors, then I'm going to work on being able to factor that. I get something that does end up, well, I put plus signs in when I shouldn't have, but something that does end up factoring these, 3x minus 2 and 2x minus 1. So my final answer for this problem would be x equals 2, 2/3, and 1/2. And if I wanted to write them as x-intercepts, it would be 2, 0, 2/3, 0, and 1/2, 0. I see that I have intercepts at 1/2, 2/3, and 2. Problem 2. They're very generous, and in problem 2 give us one of the answers. They tell us that negative 3/2 is a root. So if negative 3/2 is a root, that means that the factor is going to be 2x plus 3. Because if 2x plus 3 equals 0, that means negative 3/2 is going to be the x-intercept of that. So they give me one of the answers. So all I have to do is perform the operation. So 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18. So I'm just going to do the operation. So 2x, well, I don't want a 2x cubed. My fault. X cubed times 2x gives me 2x to the fourth. X cubed times 3 gives me 3x cubed. I then change the numbers, or change the signs in order to subtract. These cancel, I get 4x cubed, and then I pull down a minus 4x squared. I need 2x squared to multiply to 2x to get 4x cubed. And then this becomes plus 6x squared. In order to subtract, I change the signs. And this becomes negative 10x squared. I pull down a 27x. Notice that I need to multiply by 5x, negative 5x, because negative 5x times 2x gives me negative 10x squared, and then I get minus 15x. I'm going to subtract these. So procedurally, I can change the signs. This becomes negative 12x minus 18. I'll scroll down just a little bit. Then I have minus 6 showing up, because negative 6 times 2x gives me negative 12x. Negative 6 times 3 gives me negative 18. When I subtract these two things, I end up getting 0 as my remainder. So after all of that, I end up with f of x equaling 2x plus 3 times x cubed plus 2x squared minus 5x minus 6. Note again, I just take these two things and multiply them together. X cubed plus 2x squared minus 5x minus 6. And I could do the rational root theorem again. So if I look at the original problem, I could do the rational root theorem, but I can right now do the rational root theorem on this. So I know my possible answers are plus or minus 1, 2, 3, and 6. I have nothing to divide by because the leading coefficient of x cubed is 1. So I'm going to try x plus 1, which would mean that I have a root at negative 1. So I'm just going to try them in order of easiness to hardness. That's basically the best way to go about this. So if I try x plus 1, I get x squared up here, x cubed plus x. If I subtract these, or I'm sorry, this is an x squared, I end up with x squared minus 5x plus x gives me x squared plus x. If I change the signs, I end up with negative 6x minus 6. This is looking very promising. And then I can put a minus 6 up in this spot. So I end up with minus 6x minus 6 when I multiply that back down, and I get a remainder of 0. So f of x right now is 2x plus 3 times x plus 1 times x squared plus x minus 6. And then I can continue to factor that. So f of x equals 2x plus 3 times x plus 1. And then I know how to factor x squared plus x minus 6. That's x plus 3 times x minus 2. So my x-intercepts of this function are at negative 3 halves 0, negative 1, 0, negative 3, 0, and 2, 0.